Hello and welcome to yet another exciting part of learning Java language. This time we will be tackling all manners of data structures and collections that we have at our disposal at Java so that we can store data in an efficient way. So, up until this point, realistically speaking, our only way of storing data were variables. For example, if I wanted to store three variables that have some integer values in them, I need to write out stuff like this, right? Int a equals 1, int b equals 2, int c equals 3, and I would need to do it for every number that I would like to get, right? And then I would need to call a, b, c to properly get this information out. It's not very useful. It doesn't really scale well, right? If I wanted to have 100 numbers, then I would need to write out 100 variables, right? So it doesn't really make sense for me to do so. That's where data structures come in. Data structures are actually just that. They allow you to store data in a regulated and in a proper manner so that it's much easier for you to do things with large amounts of data. And in today's world, we get only bigger amounts of data than we did in the past. Right now, we're talking about petabytes of data, which is like 1,000 terabytes, which is just ginormous amount of data. So let's start from the easiest ones, right? Let's start from an array. And what exactly is an array, how to create it, and what are the qualities of an array, right? So array is the simplest type of data that we can actually create, the data structure. The way it works is that we just create an array doing something like this. I first specify the type. Very important thing. An array can only take into itself one type of data. It cannot take both integers and strings. It cannot take anything else. It just needs to be called once in terms of creation of the type of data that it can actually get into it. I use square brackets. I call my array, and it's going to equal new int. And here is the funny part. I need to write out the size of my array. I'm going to write out 10, meaning that this array will be able to store 10 numbers in it, 10 whole numbers, because it is an integer. Very important thing, I can use either primitive version of int, or I can use also the integer variant of it. As you can see here, right? Now the type matches, nothing is in red, so I can also use an object for it. So in arrays, I can store both primitives and objects. Very important thing to remember. So how exactly does it behave? How can I use it? And what are the capabilities of the so-called array? So first of all, let's talk about the size. The size, once set, it is unchangeable. We cannot really do anything about it. So if I want a smaller array or a bigger array, I need to create a new one every time. So I can't really change the size dynamically once it has been declared. In order to assign any value, first of all, I write out the name of the array object that I've created here. Then I use square brackets, and then I call the index of it. All the data within an array is indexed, meaning that it has its proper number where the data is put. So if I were to, for example, go for the first element in an array, spoiler alert, we count things in Java starting from 0, meaning that if we have a 10 element array, it means that we have indexes from 0 to 9. So I can do something like array of 9 equals 1. And then I can just print out the value. And to access the data, I can use the same syntax as I did here with array and 0. And I can just use it as I would any other variable. Let me just delete those ones and let's see how this is going to perform, what will be the outcome of it. And yeah, 1 gets printed out. But what is in this other indexes of it, right? I know that right now I have access to indices from 0 to 9. So let's try to print out array of 9. And yeah, it's filled with 0. So very important thing. an array, even if it hasn't gotten any declared data in it, will always have something. Meaning that it will always be 10 element array, even if I do not declare anything at the start. So that's a very important thing to note. If I were to call an index which is out of the scope of this array, so out of the 0 to 9 range, let's see what is going to happen. For example, 10. Then, of course, I get an exception, array index out of bounds exception, index 10 out of bounds for length 10. So this is a very, very important thing to remember, that first of all, we count from 0 and we end up at -1 number of the length of an array. And how to access the length of an array? Very easily, we can just use array.length, which is a variable, or rather a field within my array object, which holds the length of an array. So let's try to print out the length of the array I have just created. And yeah, it's 10, just as it has been declared here. This is not the only way to actually create an array. There's also another one, which requires me to pre-fill the values. Let's call it pre-filled array. Is going to equal curly brackets 1, 2, 3, 4, and 5 for a good measure. So as you can see here, what it actually does is it creates an array with elements from 1 to 5 on indices 0, 1, 2, 3, 4. So let's try and see what is the length of our pre-filled array. It's 5. And let's try to print out the 4th element of our array, which will be pre-filled array brackets number 3. And yeah, it prints out 4. So we know how to create an array. We know how to access the elements. We know how to change them. We can't really delete anything from an array. As I've said before, even if the array is empty, it will always have some placeholder values in it to make sure that those spaces are always filled with something, right? But this is just theory. This is just me writing out stuff about the array. But let's see how it actually behaves and how to use it in a proper coding exercise. So the exercise will be, I will ask the end user to input a list of names up to 5 to essentially check which of those names will be the longest one. So let's write a method which will allow me to do so. So we want to get the longest name, meaning that we will actually use a method that is public static because I'm too lazy to create an object within main that will return a string with our longest name. Let's call it get longest name, and we'll actually not get anything as an input because we will be getting the input from the user. So in order to get a longest name, first of all, we need an array to store the data in. We need some sort of a loop that will keep asking our end user about the data. And then we need to find the longest name. So let's start first with creating an array of names. The array will look something like this. String names equals new string with the size of 5. Now, what we want to do is create also a scanner to get input from the end user equals new scanner system.in. Okay, so we've got a scanner, we've got an array. Now we need a loop that will allow us to actually check, or rather gather the user input. And in order to do this loop, let's think about what would be the best type of the loop for it. We've got for loop, we've got while loop, and we've got do while loop. Actually, for loop would be the best because we can determine the amount of times that we want the loop to go on for. And here we've got a very, very specific amount of times that we want the loop to happen. And this amount of times is actually the length of our array so that we know that it's filled. So let's try to use a for loop for our exercise. The way it will work is that we'll create a for loop, create a variable I that will be equal at the beginning. I must be smaller than names.length, I plus plus. Why it must be smaller? If it were equal to the name's length, or rather smaller equal, then we would run into an issue where I would try to access the index of number 5. And this is something that we do not want to do, as I've shown before, because we will run into an array index out of bounds exception. Okay, so let's prime our user, meaning prepare the user for what we want to happen. Enter a name, and then we want to get the name into a variable, string name equals scanner.next line. So anything that the user inputs, presses enter, will be saved into variable name. And then what we want to happen is we want to assign the value to the proper index with the name. So we'll just add names of I equals name. So we are substituting the existing value with the new one that we've gotten from the scanner. So after this loop goes through, we'll have a full list of names from our end user. Then what we want to happen is actually we want to be able to select the longest one. And also one note here that I can make. I could always use in the line 20 for the amount of times that I want the loop to go through just the row number 5, as I did here. But this way, if I change the length of the array, I don't need to change anything else. It's always going to be the length of my array, so it will be much easier. Actually, I'm going to stick with 3 over here for the size of the loop, so that it's way easier for me to demonstrate how it is going to work. So now, what I need to do is we need to find out the smallest length of a name in our array. So let's create let's say a temporary holder for the smallest length is going to equal 0. And then let's create also a placeholder for smallest name. It's going to be equal to, let's say, an empty string, because yeah, that is the smallest string that we can actually create with the length of 0. So now let's just create, because what we want to do is we want to go through all the names once again and select out the smallest one. So in order to do that, we need another for loop with int I equal to 0, I smaller than names.length, I plus plus. And very important thing is that I can create 2 variables called int I within the same method, because they only exist in the scope of this loop. So I does not exist outside of this for loop. But back to the coding, what I need to do in this for loop is to actually just, first of all, check smallest name. So yeah, let's just see. If smallest length is smaller than a name, let's check names of I, and now we need to access the length of the string, because right now we are using just a string. So if the smallest length is smaller than names of I.length, then it means that, okay, let me think about it, that the new smallest name will be names of I, and the smallest length equals, okay, equals names of I dot length. Okay, and now that I think about it, the smallest length will always be smaller than names of I dot length, right? Because it is a 0. So in order to combat this, we are going to need to not assign 0, but rather names of 0 that length. So yeah, now it will be right. And what we return is the smallest name. Okay, so let's try calling this method. Get longest name. Let's run it, enter a name. Jack, John, Joe. I forgot to print it out. So let's try to print it out. And let's see what pops up. Enter a name. John, Joe, and Joe. So as we can see, something is not right with my code. Let's check live what is going on. If smallest length is smaller than names of I.length. So if this one is smaller than names of I.length, so for example, in this case, this was number 3, and this one was 2, so it will never be smaller. It should be okay, let's check after changing the sign. John, Joe, Joe. And yeah, Joe is the smallest one. So just a little mistake, but always it happens with live coding, so everything should be all right now. But to sum it up, this is the way to work with arrays. So first of all, arrays can hold both objects and primitives. They always have a static size. We cannot change it once an array has been created. You can access the elements by using the index, for example, as we do here. You can change the values in the same way by accessing the index. Then, afterwards, what you need to do is to traverse an array, you can most likely use for loop with the names.length, or rather the length of the array, because that's where the length of the array is stored, so that it's easier for you to use this information. So yeah, arrays, the easiest and simplest data collection that we have, but still very powerful compared to what we had in the past. And right now we'll be moving on to a more complicated and more sophisticated ways of storing data. So stay tuned and see you in the next video.